Hey, Algebra Half, I'm going to try to keep this brief. They got 3 parts, which is unusual for our Algebra Half lessons, each one being fairly short, and I think something you guys will all attain pretty quickly, but you can always rewatch this, or I really recommend, even if you feel pretty good, reading 263 to 264 before you get too far into the 3 practice problems. You will be doing A through C. Now, the same quantity can be added to both sides of an equal sign to solve for, in this case, x in an equation. Okay, to get to x equals, I can subtract 2 from both sides, similar to when we divided each side by the same coefficient, or multiplying by a reciprocal to both sides. We can do that with add subtract to both sides. Now don't get confused. I'm not getting x minus 2 now or something. I'm not sure how you would maybe think about this wrong. This only takes away the 2 and leaves me with an x, and then this takes away 2, leaving me with 4. I can add or algebraically add the opposite, which is subtracting both sides. And we can test that by putting 4 plus 2, and that does equal 6. And if I subtracted both sides by 2, see what happens? It's true when there's numbers in there too. I can multiply both sides by a half. I mean, you can do all these things we do with variables. And it's all true with numbers because that's what the variables stand for. Okay? So those are formats of the addition rule. You can read more examples in the book if you need them. There's even fractions where you have to subtract a fraction and then you get rid of your coefficient, 2-step problems. Now remember, a coefficient refers to the number that's attached to a letter, like the 2 in this case. Attached with what operation again? Implied multiplication. A little dot there to remind us. Now what if the coefficient were not positive but negative? Negative 2 times x. And we had that equaling 4. How would we get it to be x equals? Think about that. How do we get down to here? Well, normally, since this is multiplication, we would what? We would divide or multiply by a reciprocal. I like divide though. And we would usually divide by 2 to cancel our 2's. But that would still leave a negative x, and I don't like that. So you can actually skip a step, make it easy, and get rid of that negative, doing divided by a negative 2. That will cancel out this whole thing. So what do I need to divide by over here? Keep it simple, stupid. Negative 2. So what's my final answer? Negative 2. Okay. Just going to leave a little bit of that there for you to remember what we did. What if we had a negative 3x plus 4? Let's make this a 2-step, equaling 10. What do we do first? I don't like dividing by 3 first, because then I should really be dividing this by 3 too. So if it helps you to remember, it's almost like we're following PEMDAS, but with an equation. Let's do this actually, it's the opposite. I'm sorry. Let's not do this first. We actually want to do this first in this case. Get rid of this 4. Do the add subtract first. Doesn't this look nicer than if we had gone the other route, divided everything by negative 3? We would have had x plus negative 4/3 equals negative 10/3. See, that would still work out, but it's going to take more work. And so pick what's going to be easiest for the particular problem in front of you. And in this case, doing the division last is going to be easier. Okay? Do the division last. I feel like we could do this one more time. Trying to move quickly, but this is very important. Let's try this in some green. And let's say we had negative 2x minus 12 is 9. That's a negative. A little messy, sorry. Where should we start? Think about it before I give it to you. get rid of this first. It's going to be easier. Negative 2x is what? 21. Divide both sides by what? Negative 2x. Negative 2. Just negative 2. We need to keep our x so it goes down to the bottom. So we solve what is x? It is a negative 21 halves. Or, what's the mixed number? Negative 10 and a half. Very nice. All right, let's finish up here. Properties of equality. It just wants to make sure you feel comfortable when it asks you, what property of equality have you used? Today, we talked a lot about the additive property of equality. The addition property of equality says we can add to both sides of an equation without messing anything up or breaking rules as long as it's the same quantity. So to review, if A is B and I add C to both, that's the addition property of equality and is still true. We can call subtracting the subtraction property of equality, where this is true. I should keep this in the same order though, C minus B, because this is what I'm adding. Now multiplication property, we've learned AC is BC if A was B. And if A was B, I can also divide both sides by C. And it's still true. These are properties of equality, and today we learned a lot about the addition property of equality to solve. And then you use the division property of equality with a sign on the coefficient sometimes to get rid of that negative number on the left. Okay, do A through C.